Hello everyone, very good morning and welcome to today's webinar. We'll just give a minute before we start to let other audience join the webinar. Thank you so much. All right, I can see a bunch of them joining. Just a few more seconds. Well, all right, we'll get started. Again, hello everyone and welcome to today's webinar on MLOps. My name is Noor Basha, Marketing Director at Winwire Technologies, and I'll be a moderator for today's webinar. This is a two-part webinar series on MLOps, and today we will be discussing around secure machine learning at scale on Azure with MLOps. So specifically, we will be discussing around Databricks. So in the next 45 minutes, we will walk you through the MLOps options on Azure, the different tool sets, and how to get your modules into the productions at the fastest time possible. Before we start, let me highlight few housekeeping items. During the webinar, please feel free to post questions and we will try to answer as many as we can at the end. And we are recording this session and we'll be sharing the recording to you guys in the next 24 to 48 hours. So with that, let me introduce you to today's speaker, Pandian, who heads our data and AI practice at Winwire Technologies and brings very extensive experience in helping enterprise customers migrate, modernize data landscape, and has a deep understanding on machine learning and other modules as well. I also have Ravi, who leads the data science practice at Winwire and brings close to 13 plus years of experience in the data science, business analytics, as well as MLOps. His work on the different domains like retails, manufacturing, BFSI, and healthcare. Okay, so with that, before we jump into the actual agenda, we would like to quickly take a poll, okay, where we'll have quick, probably 30 seconds. Just give me 1 sec. Okay, so I'm launching the poll. You'll have 30 seconds to answer this. It's going on. I think this is good. All right, I think we have good responses. Then let's quickly jump on to the further discussion. Pandian, over to you to session from here.
Okay, thanks, Noor. Good morning, good evening, everyone. Welcome to the webinar on MLOps, and today we'll focus specifically on Databricks. So the key aspects which we would cover today, I think just to start with, we'll look at why MLOps is of greater interest right now, and then look at specifically how Azure and Databricks kind of supports in enabling MLOps. We'll get into a demo specifically looking at the code templates for Databricks, and then look at our recommended implementation approach for any organization to look at adopting MLOps, right? And then a customer success story in terms of how MLOps was brought into the customer data science community, right? With this, let me get into a brief about Winwire. Winwire, at Winwire, all our focus is on Azure. So we help customers adopt Azure technology to drive business growth and gain competitive advantage. And how we do it is we bring in the expertise of data-driven digital engineering, right? And our expertise on Azure as a platform on the data side or the AI has been recognized by Microsoft as a preferred partner, and as well as one of our recent winner in the AML workathon, right? So let me. So now getting into MLOps, why MLOps is of great interest right now? What is driving MLOps adoption? So definitely there's a rapid increase in terms of a lot of enterprises are evaluating MLOps in their own siloed way of building models, and there is an availability of a lot of ML software in the market, which is also driving that people to evaluate the software. Another thing is there's a greater availability of auto ML, where the skill set required for validating or running ML model is kind of limited, and you have a new role coming up, citizen data scientists who could use auto ML platform, right? Where what models to choose, what parameters has to be tuned, all of those are done within the platform, right? And there is also a greater need for ML being looked as a center of excellence at the enterprise level, right? So when you look at ML as a core center of excellence at the enterprise level, you need to look at standardization, right? Which is enterprise wide. So, and there is also ML application use cases getting into deeper into the applications, transaction applications, and with real-time integration. So all of this is actually driving towards a need for MLOps among enterprises. And we also looked at one of the recent research done by O'Reilly, which kind of supports this this understanding in terms of a lot of customers are right now evaluating ML use cases or how ML platforms, and this will lead into a larger production movement and then managing at the enterprise level. So all of this is driving towards MLOps as a greater greater demand. Right. Now, when we look at MLOps need, and when we are looking at how do I standardize my development process, or how do I manage my code? And when we say code, right, typically your development, testing, deployment, all of this has to be automated, right? And this kind of aligns with a DevOps process, which we are familiar in software engineering side, right? But there are certain specific things which is unique to ML, and we could look them as challenges also, especially like model accuracy degradation. How do I make it my model explainable? Or how do I monitor my model? How do I enable retraining? So these are very specifically unique to ML, which kind of adds additional capability to DevOps. So DevOps with additional these capabilities can actually become a MLOps system to define how MLOps can be taken up from DevOps as a base, right? So again, when looking at recent research from O'Reilly, this kind of highlights that for in existing systems which are in production, when I say systems, the ML models which are in production, the key challenges or risks they look at are in terms of the model being not able to give the, so basically the model is not being explainable. So we are not able to understand whether the model outcome is right or wrong, or whether it's the performance of the model or the accuracy of the model has gone down or not. So especially the model degradation and the unexpected outcomes, right? These are specific challenges, issues which can be addressed as found also the bias, right? Which can be addressed if by effectively bringing in an MLOps process to an ML environment. So MLOps will ensure that you are able to monitor the model, check the drift, and then kind of see whether it's within the frame, within the purpose which has been defined by the business for the model to function, right? So all of this is what driving MLOps is of great interest among our enterprises, right? Now, for us to define MLOps with the base definition of DevOps, definitely MLOps brings in an automation, and it's going to simplify the ML lifecycle management, similar to a software, how DevOps does for a DevOps or a software engineering development side, right? It's going to simplify the ML lifecycle management, and it looks at the end-to-end the lifecycle, be it data prep or monitoring or the training process, retraining process. All of this has to be an integrated process, and it has to be automated, right? And so MLOps naturally becomes a step which will help you accelerate your model development process. So basically, it help you set up a factory model wherein your model development is accelerated, your deployment and your accuracy of the model, the trust of the model that among the business also increases. Right? So the value MLOps delivers is a standardization of the process. It ensures that some of the data sets which you are using for a model development is available for the wider team. So there's a reusability factor, and there's a larger collaboration between the different roles: a data scientist, a data engineer, or a business analyst. In fact, the data scientist time will be much more productive because you'll be able to focus more on model building and rather than in operational activity. And since we're able to have we're able to reuse some data sets, have a standardized process, the application management, the ML applications which has to be managed, or for me to deliver a new application, the effort and cost for it is drastically reduced. So my total cost of ownership of my ML environment post MLOps deployment will be actually very less. So, and it will help me govern my ML landscape, manage it, and as well scale it up. So uh, bringing in MLOps is not only helping you to govern and manage, but it will also help you to scale in an enterprise-wide level. So if a department is running MLOps, building ML models and have ML applications, if that success has to be replicated across different business units within an organization, then MLOps is the first step to do that activity. So now we kind of defined what MLOps is, why it's important, what value it brings in. Now with the context of specifically getting into an Azure environment, right? So what are the ways by which I can build an ML application in Azure, right? So you could use Azure ML, you could use Databricks, you could use a VM machine or a Synapse. And for this today's session, we'll focus on Databricks during the demo next few slides. But within an Azure environment, you have these are the tool sets available through which you could build ML models. Now, for me to build the ML model and then for me to manage it and govern it and scale it, I want to bring in the ML capability. So broadly, we could we can classify MLOps capability into three areas: data management, code management, and model management. Right. So data management is getting the data ready, prepared for the model to do for training or retraining. So that's the data management part, and also making the data available for others to consume through features too. So that's data management. The code management involves whatever models I build, whatever configurations, whatever Python codes I'm building, how the codes can be version managed, how they can be baselined, how the metadata from the code can be leveraged for building lineage. So that's the code management part. The third part is model management. So that's I've built the model, but how do I register them? How do I train the model? How do I validate the models? How do you make it available for consumption? How do I deploy it across different environments? How do I monitor it? And how do I decide when to retrain the model? So all of this is model management. So if all of these three areas are addressed in an MLOps environment, then that environment is a highly mature environment, right? But for an organization to start with, it's not necessary all of this have to be addressed in the first step. So for some, data management could be a requirement, but may not be step one. The step one could be just code management plus model management till deployment. So that could be your MLOps 0.1, right? MLOps 0.2 could be getting monitoring and retraining, and MLOps 0.3 could be the data management. So you could take different steps to reach your final maturity model, and how these capabilities leveraged in an enterprise can decide where they are, whether they are in point 1, point 2, or point 3 of the MLOps process. Now, for all of these capabilities to be enabled, there are specific tools which has to be brought together, and based on which environment you're building your ML models. If you're in Databricks, then ML Flow, DevOps, GitHub can be a combination of tool sets which could be used, right? If it's Azure ML, then there's a different set of tools can be brought together. So based on your MLOps ML environment, right, how you're building your ML models, these tool sets can be brought together. Now we will specifically look at how Databricks is helping in building ML applications or ML models, right? What are the different components within Databricks? So within when I'm going to build my model, I need to have access to the data. So one of the best ways to store the data is in a DDLS with data lake in a Databricks environment. And then the machine learning runtime environment, right? And at this point, most popular frameworks are supported. TensorFlow or Keras are supported in the Databricks environment. And I have my data store, I have my runtime learning environment, machine learning ML runtime environment or libraries. And for me to build the application, there are two options. Either use notebooks and build custom models using Python, Scala, Java, or R, or I could use the AutoML model, which can actually do select the model and tune the parameters for me to run the model. So both options are available, right? And both options, whatever code I'm creating is managed using a model purpose. So in which can integrate the DevOps or GitHub, right? Your code migration, your access control, workflows, CI/CD process, all of this can be managed. So we have the data, we have the runtime library, we have the workspace to build the code, and then we have the repository to manage the code. So the code management is done. The data management of bringing the data to the notebook is also available. Now, how do I serve the model? Right. So how do I serve the model? Especially in Databricks, I could actually align it with this serverless compute, right? So for scalability. And how do I monitor the model? And then that's where ML flow also plays a role in terms of your model registration, your model serving, monitoring. All of this is managed with using ML flow effectively, right? And the other thing is some of the data sets which I'm using for training, right? How do I make it available for others to consume? In fact, for me to actually do a stress testing or regression validation of the model after a certain time frame, how do I reuse the data set, right? So that's again a feature store is another aspect of the overall capability which Azure Databricks brings together for me to build my ML model. So these are the different components which I would consider when I'm going to build a model. And all of this is what has to be brought together as an integrated process with automation to simplify the ML management process, right? So with this idea in terms of what are the components, MLOps is what are the different ML components which Databricks brings and how it's going to help us in building MLOps process with Databricks. I would like to hand it over to Ravi to talk about a specific scenario of MLOps on Databricks and also at the quick demo. Ravi, you're there, Ravi?
Yes, Panyan. Able to see my screen?
Yeah. Yes.
Hello?
Yes. Sir. Yes. You can see Ravi.
Okay. Thanks, Panyan. So before going into the demo, I just like to give you a flavor of how the architecture for a MLOps application looks like in Azure Databricks. So to start with, we have different environments like the devs, QA, and the production environment. And in Databricks, it depends on how you configure these environments. It can be within one Databricks instance, or for you can have different Databricks instances separately, where one for dev and one for QA and one for production. We're going to see how the consumption happens in both the scenarios in our demo. And if you look at the components that are across the architecture, it kind of serves all the purpose, like starting from Delta Lake for the data storage, and then notebooks for model development, and then feature store, and then we have ML flow for model tracking, and then registering, logging the parameters, and then serving. And for data drift, we can use the NanoML or the custom packages like SIPy, the stats model based on comparing the distributions. With that, I would like to so also there is aspect of code versioning to it. We can either go with Azure DevOps or GitHub, or Databricks is having its own data versioning. So in our demo, basically we are going to cover three parts. There are three notebooks that we are going to cover. Which first one, which speaks about model training, tracking, creating a feature store, registering the model, and then transitioning it across different environments. And the notebook 2 speaks about how the model serving will happen. And the notebook 3 speaks about how the data drift is can be handled in Databricks, Azure Databricks. So the model that we are going to build, we are going to use a wine classification data set, and we would like to quickly go into the Databricks. In this notebook, we are going to see these aspects. Like we are going to develop a machine learning model and track it using ML flow, and then we are going to create a future table and push it to feature store, and then I'm going to take you through how ML flow manages end-to-end model management lifecycle. So as a first step, we are going to import all the required packages, as you know, which is the basic step for building any machine learning model or application, or rather MLOps per se. And here we try to give you, kind of uh, intuitive thinking, like how we can use widgets in Databricks. So these can be used as input for your notebooks where you can automate the runs. This is good to have, but not need to have. We just want to give you a flavor of it, how it looks like. And then we kind of query the data from the DBFS. So we have uploaded the wine classification data set into Databricks file system, and then we are going to query it from there and then load the data into PySpark. And then we are going to create a feature table out of it. So this feature table is what we are going to register into the feature store. So before registering it into the feature store, we need to create a primary key, because that's a prerequisite for any feature table in order to get registered into the feature store. And we are creating a primary key, and then we are going to push that feature table into a database. For that, we have created one specific database for this feature table, and then we are going to create a feature store. This is how we are going to create a feature store and push the and register the feature table into it. So this feature store, we can browse the different feature tables that are available and see upstream and downstream activities along with the freshness, and it can be consumed across different projects. So let me give you a flavor of how the feature store looks like. This is a new feature. So so if you go into the Databricks and if you go into the machine learning workspace, so there will be 3 workspaces for which you need to go into machine learning workspace. Then you will see these experiments, feature store, and models. So when you go into the feature store, you will have you can see all the different feature tables that are available. So this is the feature store that we have created for our demo purpose. So you can see all the statistics about it, like which model or which notebook has produced this feature store, whether it is available online for consumption or not, and what are the different variables, or rather I would say schema, that is available, and which can be used later. And once we have created the feature store, we can start training our model. And so for that, I'm going to create a function which will track the accuracy metric, AUC score, in order to log it as one of the parameters in my ML flow server to monitor the performance of the model. So before jumping into the model building part of it, I'm going to split the data into train and test, and then I'm going to into the model building. So before that, we are going to start the ML flow server. So this is where all the this is the stepping stone where we are starting the ML flow server, and we start recording all the model related activities in the ML flow server. So once we have defined this, it is going to track all. We are going to log the parameters that we want to uh, uh, keep a track of, and metrics, and as well as the model run. So once we define this, then we are going to run that, and we are also going to keep a track of runs for that particular model. I'm going to take you through all these things, like how it looks like, and how different experiments looks like, and all. So after training the model, we are going to log the parameters, and then then comes the registration, model registration. So this is similar to what we call it as a deployment. So in Databricks, once you register the model, that's how you're going to deploy it, and then it is available for consumption. So it's pretty simple to register the model using the API in MLflow in Azure Databricks. Okay, so once we register the model, we can actually look at different runs that are available, and we can do the transition. So let's have a look at how MLflow looks like. So if you go to the models section in the Databricks, you will see all the models that got registered, and you can see in what stages they are, like whether it is in production or in staging, what stage it is. So once you click on any of this model, you can see what are the different versions that are available and which version is in production. Okay, and also you can go into any particular version to see uh, uh, what that particular version is, whether it is in what stage, and also you can go to the run and see what are the different artifacts that are available. So artifacts consists of your model pickle file and Python code and other things. You can also see code snippets which you can use for serving purpose here. Okay. Now, also want to show you how different runs for a particular experiment looks like. So if you look at this, so we have 3 different runs, and this is the one which is there in our production. And also we can navigate to the same path using uh, experiment, which we can see here. If you click on here, it will show you the experiment runs that are available, which you can navigate through. So this will also take you to the same path. Now, what next? We have registered the model, we have built the model, we have registered the model. What next? Now comes the transition. Like, you have built your model and you have registered the model in a centralized repository of MLflow. All these things happen in dev. Now you need to test it whether everything end to end happens fine or not. So that's where you need to transition your model from dev to QA, and then QA to prod environment. So there are 2 ways to do it. One is using MLflow UI, and the other one is using MLflow API. So this the method, the code which we are seeing here is through MLflow API, which is pretty simple and straightforward to do the transitioning. And now let's look at how we are going to do the transitioning through MLflow UI. So if you go to the model that we have developed and pick any version of it, okay. So here you can see what stage it is. So if you want to change it from uh, staging to production or production to archive, whatever it is, you just check this out and then click OK. And then once you refresh it, you will get a request to approve. So once you approve this, it is going to move from production to staging back. Like this, you can do the transitioning using the MLflow UI. Okay. So after transitioning, we need to get the latest model that is there in the in any of the environment that we are working with. Like for example, if you are working in staging, then also you need to get the latest model. Similarly, in prod also you need to get the latest model. Now we are done with model training, tracking, and registering. What next? We need to serve the model for business consumption, right? So that's where we are going to use the developed model to serve it for business consumption. So this notebook covers how we are going to consume the model. I mean, how we are going to serve the model. There are, a couple of methods to it. One, consume it from whichever the centralized repository you have, and then call the model, or you can use the MLflow for serving mechanism. And the model consumption depends on also depends on how you configured your Databricks cluster. So if you have only one cluster within which you have all these 3 environments, then there is a way to consume it. If you have independent clusters, like one cluster for dev, one for QA, and one for prod, then there is a different way to consume it. So let's start looking at how we are going to do that initially, as we start importing the packages. And if the model model is there in one, if the environments are there in one single Databricks instance, then this is how we are going to consume it. You just call the MLflow client and get the latest version, which is registered in prod, and you'll get the latest version and you can start serving it. And similarly, you can start the predictions. And similarly, uh, if the model is there in, say, suppose if the dev environment is there in one Databricks instance, but the prod is there in another Databricks instance, which is isolated, then using the centralized model repository, we need to create a scope and key, like the way we are seeing here. We need to create a scope and key in order to access the latest model that is deployed into the centralized model repository. Then we can do the serving piece to it. So we are going to see how the model serving happens through MLflow. So for that, we need to navigate to the MLflow model that we have built. So for that, we need to navigate to the model here. And then here you are looking at serving, right? So we need to go into serving and we need to enable the serving. Once we enable the serving, we need to kind of go into the clusters, and we need to select a cluster where this serving happens. So you have different options. Once you select the cluster, the model serving will start. Post that, you need to look at uh, this code snippet, which will actually call the model that is which will send the data for this particular serving point where we have the ML flow. So the model can be served using ML flow model REST API. This is how we serve the model using ML flow. Now we have developed the model, we have done the tracking, we are into serving of the model. So what next? So we need to see if there is a drift in the model in terms of data or future, or there are other concepts like model and concept as well. But then here we are going to address how the data drift can be handled. There are multiple ways to do it, but here we are going to use Nani ML in order to do the data drift. Nani ML actually provides a couple of good features. It uses, a confidence-based performance estimation in order to identify the data drift, and it actually don't need the actual or true labels for the prod data. It can compare the data drift with whatever the data we build the model. Okay, so going further, first we need to as usual, we start with the importing required packages, and then we are going to start with getting the actual data with labels, and then we are going to simulate the data, because this is what refers to the production data. Like, say suppose we have built a model for a certain period, and then for the next period we need the production data. In order to get that, we are simulating the data for a particular analysis time frame, and then we are passing this information to Nani ML, where it is going to calculate thresholds, and that a drift is going to happen in three different ways. One is using ROC-AOC drift, and the other two are univariate and multivariate drifts. So moving further, if you see this, this particular graph shows us that there is no drift. Actually, whatever the inferences that we are generating, that is pretty much within the threshold based on our model. So there is no drift which is observed based on this particular analysis. Now let's look at univariate data drift. Univariate data drift is calculating data drift upon individual variables using some chi-square statistics. So here we're going to look at each variable and see whether there is a data drift happening at a variable at a feature level. This is also called as feature drift. So if we look at a couple of features there where it's pretty straightforward, there is no drift which is happening. Okay, and here is where we see a little drift, which we can see for a particular variable called free sulfur dioxide, where we can see there is a data drift. So this particular representation shows us there is a data drift. And in multivariate drift, we are going to do the drift analysis on all the variables combined together. So if you look at here, earlier we don't have any kind of drift in our ROC curve, but while during multivariate drift, we are seeing a little drift, but this could be because of the variable that we have seen, where there is a data drift at a univariate level. So that's it from my side, and Pandian, handing over it to you for further.
Yeah, thanks, Ravi. Thanks for your demo. Yeah, thanks, Ravi. So now I think this demo would have given you a brief in terms of what are those steps to be followed and what are those code snippets which we use for automating the process, right? Now, if you have to implement that whole process, right, what's the approach? And at WinWare, we call it as MLOps approach, right? And the first step for us to get into defining a roadmap or implementation of MLOps is to look at determining what is the scope. What kind of work I'm going to build as part of my implementation, right? So from that perspective, the architecture design. So architecture design is in terms of my MLOps steps, services, how it's going to work in the existing environment, across what environments. Do I have 3 environments like dev, QA, prod, or do I have another beta environment as a 4th environment? How many environments I have? And how are the applications consuming these models? Are they API services? Are they embedded within the platform, online platforms? So getting to know the existing landscape interfaces and then designing architecture is one of the primary tasks. And the second is, once I've designed my architecture, I need to set up the environment for me to run those whole process, right? To what we saw and Ravi's showcase, right? There are 3 environments across which the code moves. So I need to ensure that, and also whether it's going to be 3 different clusters I'm going to use for Databricks, it's one single cluster. Those will be the design aspect, but setting up the environment is the next step of the scope of work. Once the architecture and environment is ready, then we go back to the 3 capabilities which we saw earlier, right? The data management capability, code management, model management. These 3 together is what will help us have a higher maturity MLOps implementation, right? In data management, to what we saw last time, the versioning capability, the data prep activity, getting the data ready for the model testing and validation process. The code management is whatever code I've developed, right? So that's how do I manage it? How do I version it? To what we saw earlier, right? How will I make code move from QA to development? How will it move it from QA to production, right? So that's the code management part. And the model management, actually the whole process of automating the validation process, when to retrain the model, getting the flags from monitoring process, like how do I find the drift and then reinitiate a retraining process. So all of those related tasks is the model management. So primarily these are the areas which we will actually put effort towards development, right? Now, once I know the scope of work, there are certain things which we need to ensure that we have a good visibility on these 6 areas, which will ensure that our MLOps implementation is successful. So when MLOps implementation is successful, means that there are a lot of models built on the MLOps framework, and a lot of the data science community team is getting onboarded to this new full framework, right? Only that ensures that it's successful. But for that to happen, there are 6 key things which we have to look at. One is the current state of ML maturity. How is the model being built? How it's deployed? Are there any challenges in the existing environment? What is the current process for version management? Is there something available right now? Or how are the teams distributed right now? So that's the point one. Second is, the model which we build should be reproducible, in the sense with the same set of data set, it should be able to give the same output. So that's the, and we're not going to look at the model accuracy in terms of whether it's able to bring the output, but the process around it, surrounding it in terms of making data available, the same data set, the same parameters, storing those parameters and making it available. So that's what we mean by reproducibility. And whatever activities which we do, testing, validation, or deployment, it has to be automated. Automation first should be the focus for us to ensure that MLOps implementation is successful. And then the scalability part, for especially for model serving, and compliance, especially to ensure that bias component is taken care, or in terms of any drifts which are against outliers against the model degradation process, which kind of address which is not meeting the business purpose. So those has to be captured as part of the monitoring process. And another key aspect is the people, right? So the existing data science team should be ensured that they're onboarded to the new framework and principles, and they're upskilled, and there's an evangelization process to onboard them to the new platform. So once this is done, then actually the overall roadmap, once we have an understanding of the scope and we know the key considerations, we have an handle on that, then the roadmap could look at something like this, where in the first 2 weeks we look at a maturity assessment process, where we understand the current how the ML models are built, deployed, how it's used, the current team structure, and with this we also kind of identify the couple of models which can go through the whole MLOps development process, implementation process, and then it becomes a framework for other models to be onboarded. And then the overall architecture setup, it could be a kind of activity, and then the 4 weeks for MLOps implementation. This is a typical timeline which we have come across. And then once the maturity assessment is done, the architecture setup is done, and I've built my MLOps model, then you start onboarding your models, or new model development happens within the framework, right? So the outcomes of each phase is primarily in maturity assessment. I know my current maturity, ML maturity level. I have an implementation plan. I've identified my scope for building my ML ops implementation, and then I have the architecture environment setup being done. And once this first 3 is done, then I start onboarding so for this MLOps implementation 4 weeks, I might be onboarding 2 models, but the rest of the models I'll be going through the onboarding models, or new model development will happen to the 4th phase, right? So this customer success which you're right now seeing on the screen is a professional services firm, specifically in healthcare industry. They had built Python-based models earlier, but the overall organization was moving towards Azure. So overall applications were getting migrated to Azure. As part of that, this Python platform was also to be migrated to Azure, but it was decided that Databricks will be the platform which will run this Python model. So as before the migration started, we built the overall framework with MLflow and Databricks as the MLOps framework, and then we migrated those Python models to the Databricks platform. So in fact, before this, a lot of deployment work and work related to retraining was actually done manually. So that's a major benefit they had as part of the MLS process. Both those manual processes eliminated, and they were able to actually save effort spent on those activities. And this also gave them a leverage in terms of how the best practice done by this particular business unit, how it can be taken up to other business units across the enterprise. So this is something which we did as a help customer on top of MLOps in a database environment. How do we actually help customers from WinWhy perspective? We have our MLOps offering, which comes with pre-built code templates, which you just now saw, or actually our part of our templates. We have delivered this for different kind of model patterns, right? When I say model patterns, how is the model getting consumed, how it's getting access. Based on that, we have various code templates which we have built, which comes as part of the services when we work with our customers. And as part of the initial exploration, we also have a toolkit for assessment, for readiness scoring, for building a TCO if you're looking for that, and then ensuring that this architecture which you're putting together is native to Azure and leverages those services. And right now we also have an offer on the Azure Marketplace. It's a 4 weeks POC where you can actually at the end of 4th week you could see actually an MLOps process running in your environment, and it will be aligned with those 3 capabilities: data management, code management, and model management. And what capabilities we choose, we will decide and then build it as a 4 weeks POC. I think I've covered with this. No?
Thanks, Pandyan. Thanks, Ravi. This is really helpful. And Ravi, thanks for quickly taking up the demo. I know we are close to the time, but I would still like to take a couple of questions which came in here. So the first question from Mark. Okay. So is there any specific kind of skill set that is required for implementation of MLOps?
Yeah. So I think just definitely, if you were to get started on MLOps, this is very critical to understand what kind of skill is required. So definitely a data science has to be part of the mix, and an Azure infra person who understands these different services, how they can be set up. That's one person. The other person would be somebody who understands the a DevOps process, as well as who has an ML knowledge. So these three skill sets will ensure that we're able to have the right mix. So it's basically a DevOps slash ML understanding person, a data scientist, and a infra Azure person would be a right team mix.
Great. Thanks, Pandian. So other question, Pandian, for you is like, in case if we build models with Spark machine learning on HD Insight, will there be any changes to the MLOps implementation?
I think this is a very good question, because since we are talking about Databricks specifically here, there's a framework tool sets which we showed for Databricks. When we move into an HD Insight kind of environment, the overall process will remain the same, but the code, the configurations, the templates will actually vary for across environment, right? So in fact, that's the reason we actually have two-part webinar series. The next part focuses on customers who are building ML models using Synapse as well as Azure ML. So HD Insight is also something which we could probably take up in the next session.
Great, thanks, Pandian. Ravi, I think this question is for you. Basically, how does the scoring happen without using ML flow serving?
So if we don't want to use ML flow serving, then we can use we can directly consume the model from the centralized repository and pass the data to the consumed model object. Then we'll get the predictions.
Okay, great. Thanks, Ravi. Thanks, Pandian. I think thanks for taking up these questions. I know there is one more question from Ashish, who is basically asking, is it possible to share sample code of classification get link? Ashish, what we would do is we will discuss it internally and come back to you. I know we have your email ID. In case if you are able to share that sample code, we would be more than happy to do that one. Thanks, Pandian, Ravi, taking time to sharing information about MLOps and Azure Databricks. Folks, again, just wanted to remind you, like as I mentioned earlier, this is a two-part webinar series. The one what we are discussing is mostly on the Azure Databricks. So we have the follow-up session, which is part 2 on September 8th. I would request you guys to go ahead and register yourself, and we will have more interesting information and insights on MLOps. Thanks everyone for taking time, and have a good day.
Thank you.
Thanks, everyone.